All right, this is 2010 AB number 6. Looks like we got some differential equation action here. So let's see what we got. Solutions to the differential equation. This also satisfies second derivative is equal to this. They didn't have to give us that, but somehow in the way they constructed this problem, they didn't have enough points to make us find this, or perhaps they didn't want, you're going to need this, and they didn't want you to blow it by messing that up. So one way or another, they gave us this, but we could have done that ourselves. So let y equals f of x be a particular solution with this initial condition, right? So that's where you separate variables, and you get there's a plus c, so you use that to find the c. All right, part A. Write an equation for the tangent line to the graph of f of x at x equals 1. Well, there's the point, 1, 2. So I just need to know what's the slope at the point 1, 2. You don't have to write it like this. That's the notation that I like. You can just write m equals if you want. But to find it, you got to plug the x and the y in here, right? That's 1 times 2 cubed, right? And that's it, right? Just write the equation for the line. Y minus 2 equals slope times x minus 1. Couldn't be much easier than that. All right, use the tangent line equation from part A to approximate f of 1.1. Okay, I'm just going to ignore the other part of the question for now. I'm going to add, to use the equation, I'm going to add the 2 to the other side, plus 8 times 1.1 minus 1. 1.1 minus 1 is 0.1. This is a no calculator problem, by the way, so you have to actually just do math here. 8 times 0.1 is 0.8, so it's going to be 2.8. It's not really very hard math to do. Okay? Given that f of x is greater than 0 for these values, is the approximation for f of 1.1 greater than or less than? If you want to know whether your tangent line approximation is greater than or less than, that's a question about the second derivative. Why? Because if you've got a tangent line, in this case we've got a tangent line with a positive slope, if the function is concave down, that means it's bending this way, which means your tangent line will be on top and will overestimate, right? And if the function is, or curve, is concave up, then that means your tangent line is going to be below. So I'm going to go ahead and find the second derivative at the point 1.1. Well, I can't do that exactly because I don't know the y-coordinate, right? But what they're telling me here is that the y-coordinate is positive, right? So the y-coordinate, instead of that little question mark, I know that the y-coordinate is positive. And the second derivative is equal to y cubed 1 plus 3x squared y squared, which is going to be a positive number cubed times 1 plus 3 times x is equal to 1.1 times a positive number squared, which is a positive number. So the approximation, if this is concave up, that means the approximation is low. It's less than. Right? My approximation, which is the tangent line, is below the actual f of 1.1 because it's concave up. So that game about is the approximation too high or too low? It's really a question about the sign of the second derivative. And they like to ask that question. Part C, find the particular solution with initial condition f of 1 equals 2. So this is where we separate variables and play that little game. That's section 9.1, if you wanted to review that in our calculus book. Okay? So separating variables, the y's have to come to this side. So when I divide y cubed over here, that's going to be y to the negative 3. The x stays on this side with the dx. And then we find antiderivatives. Bump the exponent up by 1 and divide by the new exponent. Bump the exponent up by 1 and divide by the new exponent. You could put plus c's on both sides, but since we haven't solved for it yet, you can just subtract it over and just only deal with one c. I'm going to go ahead and multiply this equation through by negative 2. That's going to get rid of those denominators. And this c, since I haven't solved for it yet, I can just multiply it by negative 2 and say it's like just a different version of some constant. And now we would like to actually solve for y. So this is 1 over y squared. I'm just going to go ahead and rewrite it like that. Is equal to negative x squared plus c1. I think I'm going to go ahead and solve for c right now. You don't have to do this. You can continue to mess around with it, but I like the way that this looks. So for c right here, I know that the curve goes through the point 1, 2, right? 1, 2. So that means the y is 1, the y is 2 rather, equal to negative 1 squared plus c1. So c1 is equal to, adding this to the other side, it's 5/4. Okay, so if I put that 5/4 here, I get 1 over y squared is equal to minus x squared plus 5/4. Now I'm going to flip both sides over. You cannot flip things over term by term because math. The whole thing flipped over is 1 over, if you like, I'm just going to switch the order of them because, I don't know, that looks better to me, but you don't have to do that. Just flip the whole thing over. And then square root. Now when you square root something, you have to put a plus or minus sign. But we know whether it's the plus or minus because of the point. It goes through the point 1, 2. So when I plug in 1 for x, I don't get negative 2, I get positive 2. So it's just the positive version of that. So that is the answer.